Geometry 6-2 parallelograms. And for most of this section, I'm just going to reveal the notes here and you can copy them down. 6-2 parallelograms. So this is what the notes are going to look like here. We're filling in this diagram and we're just doing a couple of examples. So let's talk about these parallelograms. We talked about parallelograms a little bit in the last section, but now we're going to get really into them. Parallelograms is a quadrilateral with both pairs of opposite sides parallel. So quadrilateral, four-sided object, or four-sided polygon. The two sides are, these two sides that are opposite each other are parallel, and these two sides are parallel. Parallelogram. Opposite sides of a parallelogram are congruent. So they are parallel and they are congruent. Opposite angles are congruent. So the example we did in 6-1 had to do with opposite angles being congruent. So opposite angles are congruent. And so make sure that you're pausing the video when you want to write all this stuff down here. Consecutive angles are supplementary. As in, if I were to add x and y together here, I'd get 180 degrees. X and y here, 180 degrees, 180 degrees, 180 degrees. Consecutive angles are supplementary. Now, let's do an example. After we finish this last little bit. So this is still part of the parallelogram thing here. If a parallelogram has one right angle, then it has four right angles. So if it has one right angle, then you know the opposite one is a right angle as well. Now, if this is a right angle, and this angle, the consecutive angle, is, if I add those together to be 180, 180 minus 90 is 90. So I could do that all the way around. All of these angles have to be 90 degrees. So just if one is, then they all are. And then you have a square or a rectangle. Squares and rectangles are parallelograms. All right, let's do this example. Oh, I just gave you the answers. All right, let's do this example here. So we're going to draw a basketball hoop from the side. And we're going to draw one of those basketball hoops that have the two poles coming off like this. And you can adjust the basketball hoop to go up and down, which is super fun because then people who are shorter, like myself, get to still slam the basketball into the hoop like you're a superstar. So we have here, formed by these two poles, a parallelogram. So these points here are the vertices of this parallelogram. A, B, C, and D are the points. Measure of angle A is 55 degrees. The distance between A and B is 2.5 feet. And the distance between B and C, I mislabeled these, sorry. This one should be C here. This angle should be C and this one should be D. Fix that. Okay. Great. Now BC is 1 foot. Find DC, measure of angle B, and measure of angle C. Okay, I'm going to say, if you feel comfortable with this, knowing all of this information that I just gave you, go ahead and pause the video and get to work on it. If not, I'm still going to go through it right here, but I just thought I would give you a chance to say, oh, I'll pause it right now and get to work and do kind of a you try here. So go ahead and do that now if you want to. Otherwise, here we go. Measure of angle A is 55 degrees right here. And I'm gonna look at the angles before I look at the side, because I feel like it. Measure of angle A and measure of angle C are the same. And so, yeah, there's measure of angle C right there. Measure of angle A and angle C are the same because they are opposite angles. So angle C is 55 degrees. Now, I need to find measure of angle B, which is this one. Remember, if I add A and B together, I get 180. So if I say 55 plus measure of angle B, then I should get 180 degrees because they are supplementary. So I can just subtract 55 from each side, and I get measure of angle B equals 125. Now I want this side angle here, DC. So here's DC, and DC is opposite of AB. So since this is a parallelogram, opposite sides are congruent. So DC is congruent to AB, which is 2.5 feet. And that's how you do that one. So we got a couple more things to write down and one more example before we're done with this section. So diagonals of parallelograms. We just got two things to draw here. So we're going to draw a parallelogram. So make sure that you have this side is the same length as this side, and this side is the same length as this side. This isn't necessarily a diamond, though a diamond is a parallelogram, depending on the diamond, right? Okay, let's just move on. The diagonals bisect each other. And it might be good for me to draw this, so why not? Okay. So if I draw a parallelogram like this, and I'm just redrawing the same one I was just showing you, A, B, C, D, just so it can be clear. DA is congruent to CB, and DC is congruent to AB. So those sides are, opposite sides are congruent to one another. If I were to draw a diagonal, that's from C to A, that's my diagonal. And then D to B, that's my other diagonal. And if this point right here in the middle is point P, that's where the two diagonals intersect. Now, CP and PA are congruent. So I put 1, 2, 3 marks on those because I already used 1 and I already used 2. DP and PB, those are congruent. So diagonals that should be a D. Diagonals bisect each other. So therefore, AP is congruent to PC, AP and PC, and DP is congruent to PB. We've got one more to look at here. And if I'm going to draw another parallelogram, let's do that here. And then this is A, B, C, D. These are congruent, these are congruent. Now, if I draw a diagonal here from D to B, each diagonal separates the parallelogram into two congruent triangles. So this triangle is congruent to this triangle. Now, if we were in class, I would say, can anybody tell me why I know that? What theorem or postulate that I can use to prove these two are congruent? And then I would wait awkwardly until somebody decided they would raise their hand. But we don't have the opportunity here. So you can see here this side and this side are congruent. this side and this side are congruent, and DB is congruent to DB. Therefore, I have side, side, side. So, by side, 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 each diagonal separates the parallelogram into two congruent triangles. Side, side, side. Now, let's do an example, and then we'll be done with 6-2. Here I am drawing a parallelogram. Oops, not super parallel there. Q, R, S, T. QT is 5x. RS is 27. We're going to draw some diagonals here from R to T and Q to S. And in the center there is P. This angle is 3Z right here. This angle PST is 3Z. This side is Y plus 4. This side is 2Y minus 5. QR is parallel to TS. And RQS is 33 degrees, and SQT is 95 degrees. And I think that is all of the information. Yep. Okay. Now, I want to know what is X, what is Y, what is Z. All right, and so now is a great time for you to pause and see if you can figure this out on your own. Do whatever you can to find X, Y, and Z, whatever you think you can do to get those, and then press play to see how you did. Okay. Now let's find X first. So here's 5x, here's 27. I know that these sides are congruent. So I just say 5x equals 27, divide by 5, x equals 27/5. That's gross, but it's the right answer. 27/5 is 5 2/5, or 27/5. Either way, it's fine. It's a yucky answer for x, but it's okay. Now, let's find y. So y, I know that TR has been bisected by QS. That means it's been cut perfectly in half. So y plus 4 equals 2y minus 5. And so I'm just going to subtract y from both sides, and I'm going to add 5 to both sides. And so 4 plus 5 is 9 equals y. Y equals 9. All right. Now I need to find z. This one's a little bit more tricky, but it's okay. This one thing that would be really helpful for you on this one is to think about these two sides as parallel, just like they are. And this QS is a transversal that cuts through these two parallel lines. And so that makes this angle and this angle opposite interior angles. Opposite interior angles are congruent. So I can just say this one equals this one. 3z equals 33, divide by 3. Z equals 11. And I have done 6-2. Good luck on the homework.